Today we're going to talk about probability. Probability is the basis of statistics. So it's worthwhile to spend a little bit of time understanding what probability is and what it means. So imagine that you went to the doctor and they gave you a pill and they said this pill's been shown to have side effects such that there's a 40% chance that you'll experience sexual dysfunction. What does that mean? Well, there's several things it could mean. One thing it could mean is that they went out and they surveyed 100 people and asked them if that were using the pill and asked them if over the last year they'd ever had one event where they had sexual dysfunction. Another thing it could mean is they went out and they surveyed 100 people and 40 of those people said, yeah, just shriveled up and fell off. Another thing it could mean is that they surveyed 100 people and they said, how many times last year did you try to have sex and had a sexual dysfunction? And the average number that was said was 40 out of 100 times. The point is, it's really difficult to tell what this means if they're not clear. And there's big differences in those three things. So when you're dealing with probability, there's two very important things. One is we have to specify what the observation is. So when we're talking about probability, we're saying, imagine that you're going to go out and conduct some sort of an experiment and observe something. So we're going out someplace where we haven't seen, we don't know what the truth is. So I want to know what the probability of it raining tomorrow is, not the probability that it's raining right now. I can look out the window and know that. I want to know what the probability of it happening someplace that I can't see is. So it's an imagination, it's a thought experiment. So imagine that I go out 100 times and I conduct this experiment and I make some sort of observation. Then out of those 100 times, how many times do I find a specific outcome? So we have a formula that says number of times I find a specific outcome divided by the number of times I make an observation, which means there's two really important things that you need to specify. One, you have to be very clear about what you're observing. And two, you have to be very clear about what constitutes an outcome. If you're not, then it's not clear at all what a 40% chance of something is. So let me give you an example. You've probably heard of the opioid epidemic. And if you look, there's this nice graph that looks like this, which shows deaths from opioids are increasing dramatically. And if you look at this graph, you probably say, what the heck happened in 2011? Well, actually in 2011, what happened was states started really cracking down on prescription opioids. And that worked, I guess, to some degree. If you look at the number of deaths from commonly prescribed opioids, you see a graph that looks like this. And you see that the number of deaths from those is pretty much leveled off. But if you look then at the graphs for the number of opioid deaths from illegal, like heroin, or synthetics like fentanyl, which are often mixed in with other drugs that people get illegally, what you see is a graph that looks like this. And you can see in 2010, 2011, when the state started cracking down on illegal opioids, people went out and when the state started cracking down on legal opioids, people went out and started getting illegal opioids because people are in pain. They need something to deal with their pain, and many of them may have been addicted, and they had to deal with that. As it turns out, after 2011, it was kind of easier for people to get heroin than it was for them to get a prescription. Unfortunately, the problem with illegal drugs is that they're not regulated, so you never know what you're getting or in what amount. So if you actually want to do something about opioid deaths, the solution would be to make legal opioids much easier to get and to offer help to the people who are getting the illegal ones, which is kind of the opposite of what we're doing. We're trying to make legal ones harder to get. So it's kind of like, imagine that road deaths were increasing, and so you went out and you made a bunch of laws to restrict the way semis drive. And then somebody came up to you and said, oh, are semi drivers killing a lot of people? And you said, no, No, it's motorcycle drivers. It's almost all these deaths are coming from motorcycle drivers. Well, then why are you regulating the semi drivers? That's just easier to do. So that's kind of the situation we're in. Now, I know it may sound a little preachy, but the important thing is this, okay? Tens of thousands of people are dying every year because we're not specifying what we're observing very well. We're lumping all opioid deaths together, when in fact there's two very different categories of opioid deaths. There's legal ones from legally prescribed things that you're getting from your doctor, and there's illegal ones that people are going to the street to get, and or the internet. And the problem is people are dying from the latter. So that's what we need to work on. The other issue here is that if we were just clear on what the observations are, we could actually make some progress on this particular problem. Okay? But it's all about specifying what your observation is. So let me test you real quick. What are the two things that you need to be very clear about when you're talking about probability? That's right, you need to specify what constitutes an event and what constitutes an observation or an experiment. Okay? Let me give you one more example. Let me pull this one up. So right next to Texas Tech, there's a big sign that said there's been 3,000 motor deaths on the interstate this year. Please drive carefully, which is probably good advice. Drive carefully, but it gives the illusion, not the illusion, well, maybe the illusion, that cars are extremely dangerous things, and they can be. They can certainly be things dangerous. However, this all boils down again, whether or not cars are dangerous boils down to exactly what you classify as an observation. So if you count the number of actual deaths in the United States, you can see from this graph that it was in 1970 it hit a high of about 55,000, and now it's about 35,000. So it's gone down a little bit over time, but not a lot. So if your observation is the sheer quantity of deaths in the United States, absolutely, those are pretty high. However, if you say, well, I'm really more concerned about what's the probability of me dying, in that case, you would need to divide that by the number of people. And if you look at this graph here, you can see that the number of people has gone up considerably over time. So if you say, what's the probability of a person or deaths per million people, you can see that has actually gone down a lot. In the 1970s, it was 45,000 deaths per million people, and now it's 20,000, less than 20,000. So it's gone down by about 2/3. If you say, well, I'm really curious whether or not cars are dangerous, well, then what you want to do is say, what's the probability of someone dying when driving a mile? And if you do that, what you see is the number of miles that people have drive has increased very much over time. So we got more people, each of them driving more miles. And if you look at this red line, the deaths per million vehicle miles has gone down dramatically. So the cars are extremely safe. We live in a big country with 330 million people driving lots of cars all over the place all the time. We do have lots of deaths, but the cars themselves are really, really darn safe. If you look back in the 70s or before that, one of the things that cars had is they had a steering column. So a steering column is this, it connects the steering wheel down to the front wheels so that you can move them around. And it's just this big metal tube that connects those things. Well, that's nice for steering, engineering, it's nice, but basically what it is a spear pointed at your heart connected to the front of your car. That killed a lot of people. So right now we have belts and pulleys, and if you have an electric car, it might even be computer driven. But we don't have steering columns anymore. That's one thing we got rid of. Another thing is we have glass now that's shatterproof. So shatterproof glass keeps you from getting cut up really badly. We have seat belts. That's another thing that we have. We have crumple zones, so cars are actually made to crumple. If you look at an old car from the 1960s, they're just these big steel things with steel dashboards and like glass glass and steering columns and no seat belts. Well, obviously, a Toyota Camry from 2020 is going to be a lot safer than that. we also have backup cameras and airbags, and now we've done things, for example, on the streets. If you drive by a street sign, you look, and instead of being sunken into the concrete like they used to be, what you'll see is they're like bolted onto a plate, and that's so if a car hits them, they break and fall off. And the reason we have all these declining danger of cars or the increasing safety of cars is because of statistics. In the 1970s, the car manufacturers didn't want to admit that cars were dangerous. And in the 60s and 70s, it became pretty obvious that they were dangerous. And so the government set up a statistical repository so they could say, when there's an accident, tell us what happened. And that's how they discovered steering columns stab people, glass cuts people, people bounce off steel dashboards. So if they're restrained, that with a seatbelt, that helps them. Airbags help people. Crumple zones help people. All of these things, all of these people that are being saved because of statistics, because we're looking very carefully at these sorts of things. All right. So statistics are like automobiles. They can be dangerous, but like automobiles, are you just going to give up on them? No, of course you're not going to give up on them. What are you going to do? What do we do to make automobiles less dangerous for people? That's right, we train people on how to use them. You need to understand how to use an automobile, because if you don't, you can get into a wreck fairly easily. Also, the people around you need to do this. The same thing goes with statistics. This class is hopefully to help you understand how statistics works so that you can judge whether or not statistics are right or wrong and understand how to use them correctly so that when you share them with other people, you can use them correctly. Just like you have to learn how to use an automobile. Same sort of thing. Don't lose faith in statistics. They're the best guesses we can make. Sometimes people don't know what they're doing, just like with cars, and sometimes they're malicious, just like with cars. But the best solution to that is not to lose faith entirely and just let people make up things. It's to understand where these numbers are coming from. Okay, that's all I have on probability. Just remember, what are we observing and what do we count as an event? And the probability is just the percentage of times or the number of times out of 100 that we expect this event to occur, given that we're observing this sort of thing. Thank you.